we're going to talk about how to graph a function in standard form. Now remember, we have three different forms we're going to look at, and we've already talked about factored form, which in general is y equals a times x minus p times x minus q, where p and q are our x-intercepts of the parabola. Standard form is y equals ax squared plus bx plus c. This should look familiar, right? We've been working with standard form for a couple of units, and we remember using the a, b, and c value to solve for our x-intercepts with the quadratic formula. So when we're thinking about standard form, we use it differently and it gives us different information than factored form, so we have to graph differently. Now a couple things are the same. If the parabola is positive, it's going to open up. If the parabola if the parabola has a positive a value, it will open up. If the parabola has a negative a value, it will open down. Remember, if it opens down, it's got a maximum vertex. If it opens up, it's got a minimum vertex. And the a value also controls how narrow or how wide the parabola will be when we compare it to our parent function of y equals x squared. So if our parabola is greater than 1, it means it's growing really, really fast. So then our parabola will be really, really, really skinny because it's going up at such a fast rate. If it's wider, it's because it's growing slower, right? When a is less than 1, it's like instead of getting $1 every day, if you were getting half a dollar every day, it's not going to grow as fast. So it's taking longer to get to a higher value. What's new? When we think about finding the vertex, we actually have to use the formula negative b divided by 2a. Go ahead and write that down a couple times to help you remember it. Negative b divided by 2a. That should sound familiar because that actually comes from the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. To find the vertex, all we need is that first part, negative b divided by our 2a, and that finds the halfway point between the two x-intercepts we would find if we used the entire quadratic formula. Remember that the x-coordinate of the vertex is the same as your axis of symmetry, right? That will cut the parabola in half. The last thing to remember is that your standard form gives you your c value. We can figure out our y-intercept just by looking at the c value, and that's because if I plug in 0 for x, it doesn't matter what my a or b value are, because 0 squared times a is 0, b times 0 is 0, and we're just left with our c value. So in standard form, just in standard form, if we substitute 0 in for x to find the y-intercept, we'll only be left with our c. Let's take this and apply it to a couple of problems here. So if we wanted to graph the parabola in standard form, well, y equals x squared minus 2x minus 3 has an a value of 1. This is positive, so we know it'll open up. Now to find my axis of symmetry, I'm going to write down my formula. I need to take negative b divided by 2a. It'll be a lot faster than having to do the whole quadratic formula, won't it? So my b value is negative 2. And we already said our a value is 1. So this will be a negative times a negative 2 divided by 2 times 1. Now be careful with your signs, right? Since it's a negative 2, that's going to change to a positive 2. And then we know 2 times 1 is 2. 2 divided by 2 is 1. So our axis of symmetry is 1. I'm going to sketch that on my graph. So I know my parabola will be symmetric around this line. In other words, this line is cutting my parabola in half. Now my vertex, if I have my axis of symmetry, I can use that to find my vertex, right? Anytime I have an x value, if I plug that in or substitute that into my equation, I can find the corresponding y value. So when I do those order of operations, I'm going to end up with negative 4. When x is positive 1, y is negative 4. I'm going to graph that. There's my vertex. And notice it landed right on our axis of symmetry because our axis of symmetry should always go through our vertex because those are both in the middle of the parabola. 1, 2, 3, 4, 5. I went down too far. Let me fix my point. 1, 2, 3. There we go. Here's 1, -4. Now I'm going to put that in the middle of my table because I like having my vertex in the middle. And now I need other points, right? I can't graph a parabola with just 1 point. We want a minimum of 5. But we've already used all the information our parabola can tell us, so what we get to do is pick an x value. Remember, the only guidelines for picking your x value is that it should be close to the number you already have. So I want to pick something that's close to 1, right? I'm not going to pick a 20. That's way too big. That's not going to fit on my graph. And our goal is to look for other points that will fit on our graph so we can have the most accurate parabola possible. So I'm going to pick 0 because 0 is easy to substitute in. So then we'd have 0 squared minus 2 times 0 minus 3. Hey, look, that leaves us with -3. That's our y-intercept. We could have actually figured that out just by looking at the c value in our equation. We didn't have to evaluate to find our y-intercept. So I'm going to graph that. Here's my 0, 3, and since it's symmetric, I'm going to mirror that, and now I know I also have a point at 2, -3. Again, I could substitute 2 into the equation if I wanted to, but we will end up with the same point we already found, 2, -3. Now I'm going to pick one more value. I'm going to pick a +3 to get my last 2 points. So that will leave me with 3 squared minus 2 times 3 minus 3. 9 minus 6 minus 3 is 0. Hey, look, we found an x-intercept. 3, 0 is one of our x-intercepts. If I mirror that point, so it's 2 away on the right, I need a point 2 away on the left. Here's our other x-intercept of -1, 0. And then we can sketch that parabola. So very similar, right? We still want the vertex, we still want the y-intercept, we still want to see where it's crossing the x-axis. We can still mirror our points, but how we find our vertex is very different in standard form compared to factor form. Let's do one more. If we had y equals -½ times x squared minus x plus 1. Well, a is -½ Since it's negative, this is going to open down. If it opens down, I know that my vertex will be a maximum. Now our axis of symmetry, again, I'm going to jot down the formula. I need to figure out what happens when I substitute b and a into -b over 2a. Well, we already decided our a value is -2, and my b value is a -1. So this will look like a negative times a -1 divided by 2 times -½ Well, negative turns us into a +1. Half of 2 is 1, so half of a -½ would just make it a -1. Our axis of symmetry is -1. I'm going to sketch that on my graph. So I know my vertex will be on that line, and I can substitute that in to my equation to figure out where it will be on that line. Now be careful with all these negatives going around here. We'd have -1 squared is a +1, and -½ times 1 is just -½ A negative times a -1 turns that into +1. +1, well, I know 1 plus 1 is 2, and -½ plus 2 is 1½ Now notice we got a fraction. We're not really used to getting fractions, but that's okay because we can definitely still graph this. Instead of going up 1 or up 2, I'm going to find halfway between 1 and 2, and there's my point. We don't have to have integer points or nice whole number points in order to graph. It's just easier, right? So most of the problems that we look at, that's why most of them end up having, again, nice points instead of our fractions or decimals. But we could graph any point we wanted to. Now, just by looking at my equation, I see that my y-intercept is 1. So I could graph the point 0, 1. And put that in my table. I'm going to graph that. Here's my y-intercept of 0, 1. And when I mirror that, I find that the point -2, 1 is also on my graph. So I've got 3 points. I just need one more. Again, I get to pick any x value I want, but I want it to be pretty close to these other ones. So I'm just going to plug in 1. I'm going to see what happens when x is 1. So when I substitute that in, I'll get a negative half times 1 squared minus 1 plus 1. Well, minus 1 plus 1 is 0. And negative half times 1 is negative half. So I'm going to go over 1 and down a half. So right between 0 and negative 1. And of course, I can mirror that and find the point negative 3, negative half. And there's our parabola. Notice that it's wider, right? If I compare it, it's wider than our last parabola because our a value was smaller. So this one's growing like at the rate of a equals negative half, so it's not growing as fast as if a were equal to 1. Let's do one more. Just to make sure, I encourage you to pause the video and try this on your own. Okay, so a is a positive half. This opens up. My axis of symmetry is negative 2 over 1, which is just negative 2. I can substitute that in to figure out that when x is negative 2, y is going to be, let's see, half of 4 minus 4. Half of 4 is 2 minus 4 is negative 2. So we have our vertex is negative 2, negative 2. I'm going to graph that real quick. Negative 2 is right here. And then jot down my axis of symmetry. And then my c value, well, here's my a, here's my b. What about my c? There's nothing there. What's our number for nothing? 0. So even though there's nothing there, we do still have a y-intercept. It's just 0, 0. So this is going to be going through the origin. So let's see. That would be 0, 0. And then if I mirror that, I'll get the point negative 4, 0. All right, I got 3 points. I need 2 more. Again, I could pick any x value I wanted. Negative 3, negative 1. I'm going to go with positive 1, right? Because that looks like it'll still fit on my graph because this is growing at a rate of a half, and so that's pretty gradual, right? It's going to be a wider parabola. When I substitute a half in, I'll get half of 1 squared plus 2 times 1 equals a half times 1 plus 2, which is 2.5. Over 1 up 2.5 would be about right here, and I can mirror that. It's 3 to the right, so I'm going to go 3 to the left. Here's the point, negative 5, 2.5. There's my parabola. So again, standard form, a little bit different than factored form. We still need to find the same information, but we use the equation negative b divided by 2a to find our axis of symmetry. And just by looking at our standard form, we can figure out our y-intercept.